All right, second section for solving inequalities. Not much harder than the first. Okay, if we start with x minus 3 times x plus 4 is all greater than 0. Well, what you do is you set each of these equal to 0. X minus, or greater than 0. Actually, I would set them equal to 0 to find your zeros. So x is equal to 3, x is equal to negative 4. Then we're going to go down here and graph them on a number line. So I have a point at 3 and a point at negative 4. Okay, so that's negative 4, that's 3. Now I have to figure out where the lines are going. Okay, so what I'm going to do is a sign test, just like I did when I graphed. And I'm going to pick a number past negative 4 to the left and put it in there. That would be negative 5 minus 3 is negative 8. Put it back in there. Negative 5 plus 4 is negative 1. So I have negative 8 times negative 1, which is 8. So that's greater than 0. Do the same thing with one in between them. Well, the easiest one in between them is 0. 0 minus 3 is negative 3. 0 plus 4 is 4. Negative times a positive is a negative, so it is less than 0. Then I pick one to the right of 3. So f of 4. 4 minus 3 is 1. Times 4 plus 4 is 8. It is greater than 0. So what we are looking for is we go back and we look at this sign right here. Where it is greater than 0 is where we're going. It's greater than 0 to the left, and it's greater than 0 to the right. Now, if you remember from the last section, I told you if this thing starts out greater than, it's an OR statement. Well, your answer here is an OR statement. So it's x is less than negative 4, or x is greater than 3. There is your answer. Okay, that's the first one we're going to look at. The second one is very much similar, except it doesn't start out factored. X squared minus 2x minus 15 is greater than or equal to 0. So I factor it. X minus 5, x plus 3. Greater than or equal to 0. X minus 5 equals 0. X plus 3 equals 0. So x equal 5. X equal negative 3. There's 5. There's negative 3. That's a 3 there. So I got a point here, and I got a point here. Again, go do your sign test. Past negative 3 is negative 4. Negative 4, okay, squared is 16. Negative 4 times negative 2 is plus 8. Minus 15. Well, that gives me greater than 0. Pick one in between. 0 minus 0 minus 15. 0 minus 15 is less than 0. Well, now I got to pick one out to the right. So 6. That would be 36 minus 12, which is 14, minus 15. No, 24 minus 15 is greater than 0. So now I look. I'm looking for where it's greater than or equal to. Greater than, greater than. On the outsides, again, it's another or statement. So I'm going to have x is less than or equal to -3, or x is greater than or equal to 5. There we go. Okay. The next one we're going to look at is a cubic. Now, if I were to graph this, okay, or not graph it, factor it, I personally would use the rational root theorem on this and find a root, synthetically substitute, do that kind of stuff that we just went over last chapter. But when you get this factored, it's n minus 1 times n squared plus n minus 6 is all less than 0. So now I set both of those equal to 0, but first I'm going to factor this one. This is n minus 1 times n minus 2 times n plus 3. So here n is equal to 1, n is equal to 2, n is equal to -3. So at -3, I have a dot. 1, I have a dot. And 2, I have a dot. This time I have to go test all the way to the left. So -4. We'll go n of -4. No, not n. F of -4 is equal to, okay? I just plug it in these three. So -4 minus 1 is -5 times -4 minus 2 is -4 minus 2 is -6. And -4 plus 3 is -1. That is all going to be negative times the negative is a positive times the negative. That's less than 0. Now I pick one in between, -3 and 1. Well, I'm going to pick 0 and give me, plug it. Okay, where I'm plugging these in again, if you can't see, is here, here, and here. So that's going to give me 0 minus 1 is -1. 0 minus 2 is -2. 0, that's 3. That's all greater than 0 because you got negative times the negative is a positive times the positive is a positive. Now I have to pick one in between 1 and 2. Well, that's 3/2. 3/2 minus 1 is 1/2. 3/2 minus 2, okay? So that's 3/2 minus 4, that's -1/2. And 3/2 plus 3 is 6, 9/2. Well, you have a positive times the negative is a negative, and a negative times a positive is a negative. So that's less than 0. The last one I'm going to pick is on the outside out here, f of 3. Well, 3 minus 1 is 2. 3 minus 2 is 1, and 3 plus 3 is 6. That's all going to be positive. Well, where do I want this thing? I want it wherever it is less than 0. So all the way out to the left is less than 0. So it's going that way. Am I done? No. I have to look at all three. Greater than, no, less than in between these two. And then the last one is greater than, doesn't work. So my answer here, I have x is less than -3, but I also have 1 is less than x, which is less than 2. So I have all of that as an answer. Okay? When you have a cubic, you're going to have more things down here for the answer than just 2. All right, let's look at one more type, and that's a quartic. Well, I'm going to factor this. Go b squared minus 4, b squared plus 4. Set both of those equal to 0. Here, b squared is equal to 4. Here, b squared is equal to negative 4. Take the square root. B is equal to positive or negative 2. Take the square root. B is equal to positive or negative 2i. My question to you on this, look at the second one. Graph that imaginary thing on a number line. How do you graph something imaginary? Well, you make an imaginary graph. We're done. Now let's just focus on this. So I go 0, 1, 2, 1, 2. Dot, dot. Do my testing. Okay? 1 to the outside is b of negative 3. Okay? So I'm going to put it right here in here. So I have 9 minus 4 is 5. And 9 plus 4 is 13. So it is greater than 0. The second one, put in 0. I have 0 minus 4, negative 4. 0 plus 4 is 4. That's less than 0. And then put in 3. And I end up with 5 again and 13 again, which is greater than 0. Well, we need to look at it. Where do we want it? We want it where it's less than. The only place is in between, right there. So I'm going to have b here, greater than. Okay, so on this, I have what? 2 and negative 2. And that is how you solve for complex inequalities. Hope that helps.